so let's go. Alright, so welcome again everyone to this another science video lesson, and in this video lesson this will be a supplementary video for the topic called projectile motion. So this video will be all about the problem solving and how to analyze, all right, how to analyze a projectile motion problems. All right, so let's start looking at this particular problem. Okay. Alright, so last time, on our last video, okay, we discussed about the concepts of this projectile motion problem. Now, from the x and y components, from the factors that affects the range and the height, which is the initial velocity and the angle. Alright, so this time we have more sample problems, alright, to deal with at a different given situation. Alright, so how to solve them properly, or how to analyze those problems properly, is what this video is all about. Alright, so if we recap, alright, if we go back to our previous lesson or previous video, on the previous video we have alright, so we have derived some formulas that we will going to use, alright, in solving your projectile motion problem. So we have now your formula for the range, we have the formula for the x velocity, and we have the formula for getting the maximum height over here, and we have also the formula for getting the y velocity respectively. Alright, now this is what the toolbox is all about. So hey, now how to utilize them at different scenarios of your problem. So let's start. Okay, so let's go to the next first sample problem that we have on this video. Alright, on this first sample problem, Squeaky drives horizontally on a cliff at 15 meters per second. Alright, so he lands 30 meters from the base of the cliff, and how high is the cliff respectively? Alright, so how high should be the cliff, alright, before this Squeaky, the driver, alright, lands, okay, from the base or from the top of the cliff down to the base of the cliff. Okay, so what do we have right here? We have 15 meters per second, and we have 30 meters from the base. Okay, so let's analyze this problem by drawing a picture. Alright, so start first with drawing a picture. Now, it is impossible to solve a problem like this if you don't draw a picture, so that you will the picture will give you a perspective on how the problem will look like. Okay, so let's go to our handy dandy whiteboard. There we go. Alright, so there you have it. Okay, so whiteboard, then let's use this one. Okay, so let's have the... Okay, so according to the problem that so Squeaky the driver drives off the cliff. So it looks like this. Okay, so this is the car. Okay, and it drives off the cliff, and probably he's a stunt master, so just drive down the cliff and lands, all right, below the cliff. Right, so if we go back to the problem, itself, so he lands 30 meters from the base. Alright, he lands 30 meters from the base, and the initial velocity of the car he drove is 50 meters per second. Alright, so let's go back to that. Alright, so initial velocity. So since that is horizontal only, so our horizontal initial velocity is 15 meters per second, and it drops, alright, it lands on the base of the cliff 30 meters. Alright, so 30 meters from it. Now, how high is the cliff did he jump with? Alright, so how high does the is the cliff? Alright, how high is the cliff that he jumped with? Alright, so we have YF, right, and we have the YI over here. So technically, we are looking for the YI. Okay, what is the initial height, okay, of the place where he jumped in? So this is our question. Okay, So now let's take a look at the problem. Let's list down all the given perspective or the given variable. So we have VIX. All right, so we have the VIX. So we have 15 meters per second. Since the problem is talking about that the object is moving horizontally, so the VIY is no need. Because that will be 0 meters per second. There's no VIY because the object is moving horizontally. All right, it is not thrown. It is not thrown at an angle. All right, next one. How about the YI? Alright, so the YI is the one that we are looking for, and the YF obviously is 0. So why 0? Because it drops from a certain height down to the zero height over here. Okay, so this is the base. Okay, so that is 0. And what's next? So we have the G, which is negative 9.81 meters per second. Right, so let's trim down our pen. Okay, so there you go. All right, so 9.81 meters per second. And what's next? So we have the range. So we have x sub f, which is 30 meters rather. All right, so how do we solve this problem? Okay, so this time it is the cliff. All right, this is the cliff height that we are looking for. So before you start, write the tools that you need. So let's start with number 1, the distance or the range formula. So we have x sub f is equal to v sub I. All right, x times time. Okay, so let's make it. Okay, so next, number 2. Okay, so let's have number 2. So we have v sub f x is equal to v sub I x. Alright, next one. Number 3. Alright, so the y direction. Alright, so the y displacement. So we have f, tapos y sub I plus v sub I y t minus 1/2 gt squared. There we go. Next, the fourth one is the velocity at y direction. So v sub fy is equal to v sub iy minus g t. There you go. Alright, so there you go. So in this case, so how are we going to attack this problem? So since we are looking for the yi, so the only formula that has yi is this formula. Alright, so the only formula that has yi is only this formula that we have right here. So probably we will going to use this one. Next one. What's next? So since we are looking for the yi, so what will happen here is, okay, so we don't have time. Alright, we don't have time for this one. If we were going to use this formula, we don't have time. So in which case we can find time? Alright, so as we all know, we don't have VIY. We don't have VIY. And we cannot utilize this number 2. So we can utilize number 1. Okay, so we can utilize number 1. So let's solve for that one. So since we cannot solve for number 3 immediately, so we will solve first for number 1. Alright, so x sub f is equal to v sub ix times time. Alright, so in this case, we can compute for the time. So the time can be obtained by dividing x sub f over v sub ix. Okay, so let's put all the values that you have right here. We have which v sub this is 30. Okay, meters divided by v sub I, which is that 15 meters per second. So we have to cancel the 2 meters. Okay, and the answer is the time is 2 seconds. 0.00 seconds. There you have it. Okay, so the time, all right, from the cliff down to the ground is 2 seconds. Alright, now to compute for the yi, so we will now compute for the yi. We can now use this formula number 3 because we have already our time. Alright, so let's compute for the formula number 3. So number 3 is yf. Alright, so yf is equal to yi plus viy t minus 1 half gt squared. Alright, so let's take a look. What are the things that we will cancel? So this is 0 based on the problem. Next one, this is also 0 because we don't have VIY. Alright, so what we left is YI, then negative 1 half gt squared. So we can simply transpose. Alright, so we can simply transpose YI. So it will look like this formula. It will look like this formula. So YI is equal to 1 half gt squared. So we are now good and ready to go. Okay, so let's let's substitute all the values. So we have 1 half times 9.81 times 2 seconds. Alright, so 2 seconds squared. Alright, so there you go. So we have times 4.91. So that will be 19.64. Alright, so that will be 19.64. Okay, so sounds reasonable. Yes, okay. So the value is somehow reasonable with the height of the cliff that you have right there. Or not meters per second, sorry. The height of the cliff is somehow 19.64. Alright, so meters rather. So not meters per second. So pardon me for that. So we have y sub I over here. So this is now the answer to our question. Okay, for the problem, how high is the cliff? That is 19.64 meters. Alright, so okay, so there you have it. Yeah. Okay, so next one. Okay, so that is our first problem. So don't forget, guys, to put always your toolbox on the side of your paper or whatever it is, so that you will not be able to forget, okay, how what formula are you going to use. All right, so let's put on some new things. Okay, so let's take a look at the second problem. Okay, now what is the second problem all about? Okay, so this time it is completely different. Okay, the object was not thrown at a place with higher on a higher place. All right, it was thrown on a level ground. All right, so a ball is thrown at an angle of 30 degrees off the horizontal with an initial velocity of 28 meters per second. What is the maximum height the ball will reach? All right, so again, before you start any problem, you should draw a picture first, because this problem looks vague if you don't draw a picture for that. All right, so let's go to our handy dandy whiteboard. So as the problem says, okay, it doesn't originate, or there's no cliff. All right, there's no cliff that is involved. So this is a level place. Okay, so the object was thrown at a certain angle at the level place. Then the object traveled at a trajectory path like this. There you go. Now let's revisit the problem to see what are the things that we have here. Okay, angle of 30 degrees off the horizontal. Now, what do you mean by off the horizontal? Okay, if this is your Cartesian plane, so off the horizontal is, this is the horizontal, this is above the horizontal. Alright, this is above the horizontal. Otherwise, below horizontal. Alright, so 30 degrees off the horizontal, then initial velocity of 28 meters per second. What is the maximum height that the ball reach? Alright, so in this problem, we are looking for the Y max. Alright, so Y max. Okay, so this is the maximum height. So Y max is over here. There you go. Now, the problem says that the ball was thrown at, okay, so the ball was thrown at 30 degrees. Alright, okay, off the horizontal, and it has a speed of 28 meters per second. Okay, so it has the speed of 28 meters per second. So this is your V sub I. Okay, 28 meters per second. There you go. Okay, so these are the components of your vector. So this is the V sub I x, and this is your V sub I y. There you have it. Okay. Now, what are the things on the problem? So let's write down all the given figures on the problem. So we have the V sub I. Okay, so we have the V sub I, which is 28 meters per second. So we have the angle, which is 30 degrees above the horizontal. Okay, next one, what do we have? We have the gravity, so we have negative 9.81 meters per second squared. There you have it. And what's next? Okay, so okay, what else do we have right here? Okay, so the height itself. So YF, all right. YF is somehow 0, right? 0 meters, and YI is also 0 meters. Why? Why 0 meters? Because we did not start on a higher place, right? In the first as the problem says, so we did not start on the higher place. So both of them are 0. All right. So let's solve for this one, and don't forget to write the formulas that you have right here. So let's have for the range. Okay, let's write the formula for the velocity formula for x. Okay, v sub fx is equal to v sub ix. All right, next, number 3, the formula for the y displacement. Okay, so y sub f is equal to y sub I plus v sub I yt minus 1/2 gt squared. There you go. Next one, number 4 is the velocity at y direction. So we have v sub fy minus is equal to rather v sub iy minus gt. There you have it. All right. So what are the formula that we were going to use? Okay, to compute this y max over here. Number 1. Okay, the first thing that you do is to draw the picture. We did it. All right. The second thing that you do is to write all the formula. All right. Next, the third thing that you do is to break down this thing. All right. So break down this thing into its component, the v sub iy and then the v sub ix. Because if you break down this one to its component, we will now be able to solve what is on the problem itself. All right. I think we left something on the problem that we forgot. Okay, the maximum height that the ball reach only. All right, not the range. Okay, so we are not looking for the range, only for the maximum height for this problem. All right, so let's answer this one. Okay. Okay, now to break down the v sub I, we will use the SOHCAHTOA. Okay, so we will use the SOHCAHTOA. So to get the v sub I, okay, so to get the v sub ix, so I will use blue. Okay, so to get the v sub ix, so you get v sub I cosine theta. There you have it. Then for the v sub iy, you get v sub I sine theta. Okay, so there you have it. Okay, so let's solve for this one. So for the v sub I, alright, so for the v sub ix, so that will be 28 times cosine of 30. There you have it. So for the v sub iy, okay, so we have 28 times sine of 30. There you go. Okay, so what will be its answer? What will be the answer to that? So v sub I, then v sub iy. Okay, so what will be the answer? So 28. Okay, so cosine of 30 times, times 28. There you have it. So we have 24.25. Okay, so 24.25 meters per second. Next one, the v sub iy. Alright, so we have sine 30 times 28. So do you have 14? Okay, so we have 14 over here, 14.00 meters per second. Okay, so let me double check. Okay, so I got the correct things that we have right here. Okay, so we can now compute for the things that we need, especially this one. Okay, now, since we have your v sub I, okay, v sub ix, okay, so there's no range that is stated here. So we will not use this two formula over here. So we will not use these two, only this one that we have right here. Now, Now, to compute for the y max, so we will use the formula for the y max number 3. Okay? Now, we will use, the y max here will be the final height over there. Alright? Not this one. Alright? Not this one. The final height. We will treat this one as final height. Alright? The final height that you have right here is this one. This one over here. That's the final height. But this one over here will be the y max. So, now, certainly number 3, we cannot use number 3 because we don't have time. Okay? We don't have time. So, we will use number 4 to solve for the time, then followed by number 3. Alright, so let's solve for number 3. Okay, let's solve for number 3. Number 4 rather. So, we have v sub fy is equal to v sub iy minus gt. So there you have it. Now, as we all know, based on the discussion of the concept, that as the object reached its maximum height when it was thrown, then therefore its velocity, alright, its velocity on that maximum height is 0. So, what is that velocity? Obviously, that is the final velocity that we are looking for. So the final velocity here is 0. Okay? So 0. So what we have right here is the VIY minus GT. So to compute for the time, all right. So to compute for the time, so we will have So we will have time. All right. Time is equal to VIY equals over G. Okay. So there you have it. Alright, so VIY over G. So the negative sign is being eliminated, alright, in this process, or being cancelled. So the time itself here is VIY. What is VIY? So 14 divided by 9.81. There you have it. Yeah, 9.81. So what will be our time? Alright, so what will be the time answer? So 14 divided by 9.81. So that will be 1.43. Yeah, 1.43 seconds. So this is the time that we will going to use on number 3. Now, let's plug in number 3. So we have y sub f. Okay, so we have y sub f is equal to y sub I plus v sub iy t minus 1/2 gt squared. There you have it. Now, we can cancel this one since this is 0. Alright, so since that is 0, so we can now proceed to the computation. So, substitute all the values. So, we have VIY, okay, which is 14. Alright, times 1.43. Okay, minus 1/2 GT. Sorry, 1/2, I forgot to write the 9.81. Times 1.43 squared. There we go. So pardon me if the workspace is very dirty. Alright, so okay, so if you do the correct math, okay, so if you do the right math there, so the y max that you will compute is, so the maximum height that the ball will achieve is 10 meters. Okay, so this is now your final answer for this question. Okay, so that is 10 meters. Okay, for this question. Okay, so a soccer player kicks the ball, then it reaches 10 meters. That is its maximum height. Okay, so that is for the second problem. Now let's go to the next problem. Okay. So let's have another set of new whiteboard. Okay. Right. So what I like about this digital whiteboard is this is very economical because I will not use something like a whiteboard marker. All right. So and then erase it again, then whiteboard marker, erase it again. So something like that. Okay. It's very handy. Okay. Next one. Okay. The third problem. Alright, so it's still the soccer ball. Alright, so we have a soccer ball over here. Okay, so we have a soccer ball that is kicked at an angle of 45 degrees off the horizontal with an initial velocity of 25 meters per second. how long is it on the air? All right, so we have we need to answer these two things here. How long is it in the air, or the what they call hang time? All right, the hang time. Now, what is the horizontal displacement? All right, so what is the horizontal displacement of this problem? Okay, so horizontal displacement, or so-called as range. All right, so what are the things that we are going to have here? The angle of 45 and the initial velocity of 25 meters per second. Now, there's no cliff. There's no cliff involved here, so this is a level ground. All right, so this is a level ground. So let's go to our whiteboard. There you have it. Okay, so first things first, draw the problem. All right, so let's draw the problem. So this is a level ground, something like this. All right, so that's a level ground, and the person kicked that ball, and it goes upward. So it looks like this. It goes upward. There you have it. Okay, so what is said there, that the projectile is launched at 45 degrees. Right, 45 degrees of the horizontal. So meaning to say that it is above horizontal. So we can put it right there. There you go. All right, so 45 degrees. So I hope I have the 45 degrees. So pardon me for that. And we will have the v sub I. All right, so v sub I x and the v sub I y over here. So v sub I y. So there you have. Okay, next one. What is the speed the ball was launched? Okay, 25 meters per second. Alright, so let's take a look. Let's put it right here. So that is v sub I. That is 25 meters per second. Now, the problem was, alright, so the problem was looking for the following. Now, how long is it in the air? So that will be the total time, T total. Alright, so from this point down to this point, so that's the total time, so we don't have it yet. Okay, next one is the range. So from this point down to the point where the projectile lands, alright, so that is the range, so x sub f. Alright, so we are looking for the x sub f. So these are the two things that we will going to look for. Alright, so these are the two things. Now, okay, so let's start with writing all the given values that you have on the problem. Alright, so we still have the angle, so we have 45 degrees. Okay, so we have the v sub I, which is 25 meters per second. There you have it. We have the yi. Alright, yi is 0 meters. Okay, because we started on the level ground, so it's not a cliff. So yi or yf will be that is 0 meters because it still fall on the same level ground. Alright, so both of them are 0. Next one, the acceleration due to gravity, that is negative 9.81 meters per second squared. There you go. Okay, so what else? Okay, so I think this is all, or these are all the given values. All right. So first things first, write down the formulas that we will going to use. So we have x sub f is equal to v sub I x times time. There you go. Next, number 2, we have v sub f x is equal to v sub I x. Then number 3. Okay, number 3, we have y sub f is equal to y sub I minus, alright, plus rather, v sub I y t minus 1/2 gt squared. There you go. Next, number 4, the fourth formula will be the velocity formula for y. So we have vfy is equal to v sub I y minus g. So there you have it, and I think we are good and ready to go. Okay, so what formula are we going to use? Alright, what formula are we going to use? Now, since this is a level ground, if you divide this by 2, if you divide the problem by 2, as you can see, whatever time it takes to get in here, alright, whatever time it takes to get in here is the same time that it takes to go down there. Alright, so let me repeat. So, since this is a level ground, you cannot do this on the cliff. Alright? So, you cannot do this on the cliff. Alright? So, whatever time it took here is the same time it took, or is the half of the time it took on the other side. Alright? So, meaning to say, to compute for the total time, you need to compute for the half of this total time. Alright? So, the half of this total time. So, mainly, we will compute the time it takes to go at the highest or Y max that we call. Alright? So, this is what we will going to use. We will not going to use anymore the complete journey. We will not compute. We will not use anymore the complete. We will not. We do not need anymore to compute the complete journey. All we need is this point, okay, to compute for the total time. All right. So let's try out. So what are we going to use? Since we will going to use the maximum height. All right. So we all know that the velocity here is 0. So therefore we will use this one. Okay. Since the problem is not looking for the YF, alright, or the maximum height, so this is not applicable. Alright, also number 2 is not applicable. And since we are looking for the range, so this is applicable. Alright, so let's use the formula that we selected, okay, in this process. So let's start first with breaking down this one into its v sub x and v sub y component. Alright, so you all know already that v sub x is equal to cosine. Alright, so cosine times cosine theta times the v sub I. Okay, next one, the v sub iy is obtained by sine theta v sub I. There you go. Alright, so doing the right math properly. Okay, so doing the right math properly, so v sub ix and v sub iy. So if you do the right math properly, so since that is 45, all right, cosine of 45 is equal to the sine of 45. So times 25. So there you have it. So that is 17.68. All right, so both of them are 17.68 meters per second. So also on the v sub iy, that is 17.68 meters per second. So there you go. Okay, so this is very important. So we need to box this one. Okay, so next. So since we cannot compute for the range without the time, the total time. This is the total time that we need. Alright, so we will compute first the time at midpoint. Alright, so the time at midpoint. Okay, so how to compute for that one? So we have v sub f y is equal to v sub iy minus gt. There you have it. Okay, so next one. What do we have right here? Okay, what do we have? So since this is 0, we all know that the final velocity at the midpoint is 0. So therefore, we can change this one to become time is equal to viy over g. So that is, what is the viy? Which is 17.68 divided by, okay, divided by 9.81. Okay, so there you go. So what is the time? Alright, so the time is 17.68 over divided by 9.81. Okay, so the time it takes to go at the halfway point is 1.81. Alright, rather 1.80. Okay, so the next number is not 5 and above. Okay, 1.80 seconds. Now, to compute for the total time, we need to multiply this by 2 because, okay, this is half, alright, half of each other. So, we need to multiply it by 2. So, the total time will be, alright, so the total time, the total time, to be exact, okay, so the total time is, okay, 1.80 times 2, that is 3.6. Alright, so the total time is 3.6 seconds. Alright, so that is our total time for this problem. Okay, so we answered one already, so check this one. Okay, so let's compute now for the range. Now that we have the total time, we can now compute for the range. So we can now use this one, x sub f is equal to v sub ix times time. Okay, so there you go. So what is the v sub ix? So that will be 17.68 times the time, which is the total time. This is the point that we are talking about. This is the point, right? So it's the point. So we have 3.60 seconds. So that will be 17.68 times 3.60. So that will be 63.64. Okay, 63.6. Alright, 63.6 meters. So that is our range. Okay, so there you have it, guys. Alright, so 63.6 meters is our range for this problem that you have. Okay, so we already now answered this question. Okay, so let's move on to the next problem. Okay, let's have another whiteboard and let's read the next problem. Okay. Now, this is a very interesting problem, okay? Because this problem, okay, the horse will jump from the cliff. Okay, I don't know if this is possible in reality. Okay, so the horse will jump off the cliff that is 100 meters wide. All right, and the flight through the air takes only 5 seconds. All right, so the hang time from this point, right? So from this point to the other side of the cliff, that is 5 seconds. Find the initial velocity, find the magnitude and the angle of that initial velocity. So let's get right into it. Okay, so what are we looking for? The initial velocity. Okay, the initial velocity and the most important here is the angle of the initial velocity. All right, so let's use the whiteboard. Okay, so this is how it looks like when it is drawn. Okay, so this is the cliff. Okay, so supposedly it looks like that. So this is the horse. All right, so this is the horse, and I think the horse will jump off the cliff. There you go. And the cliff has from this point to that point is 100 meters. There you go. Okay, so the time it takes. Okay, so the total time. All right, so the total time it takes is 5 seconds to jump from this point to this point. All right. So what are we looking for here? What are we looking for? All right, so the one that we are looking for is the v sub I, this one. All right, so we don't have this one. Okay, so that's the one that we are looking for. By computing its component, we will be able to get the v sub I that we are looking for. All right, so the component which is v sub I y, there you go, and v sub I sub x. Okay, now let's put on the variables that we have. So we have g, which is negative 9.81 meters per second squared. Okay, let me... There you go. Okay, so 9.81, then so the yi is 0 meters because that is a level ground. All right, that's not a cliff. Okay, so next one, assume that the other cliff is not higher than the other one, so 0 meters as well. All right, so we don't have v sub I based on the problem, so that is the one that we are looking for. Not the x component, not the y component, but the v sub I, this one. All right, so and also the problem is looking for the angle the object launched. Okay, so what do we have? We have the range, which is 100 meters, and also we have the total time, e total. So that is 5 seconds. All right, now let's put on the formulas that we will going to use. All right, so we have number 1, we have x sub f is equal to v sub ix times time. Tapos number 2, next is number 2, we have v sub f x is equal to V sub ix. Next, number 3. So we have yf is equal to yi minus vi, not minus, that is plus, viy minus 1/2 gt squared. gt squared. Next, number 4 is v sub fy is equal to v sub iy minus gt. There you have it. Alright, so what do we have right here? Okay, so what do we have right here? Now, how to compute for this one? Okay, now let's take a look first at the problem. So this is the total time. Since this is a level ground, so the total time it takes for the object to go from this point down, from this point over here, down to this point is 5 seconds. Alright, the total time. Now, since this is a level ground, we can say that the total time, or the midpoint, which is this point that you have right here, this is the midpoint. Okay, the midpoint has the half of this total time. Alright, so has the half of that total time. So the midpoint has the half of, that is 2.5. So 5 seconds divided by 2, that is 2.5 seconds. So we already have the half of the time. Okay, a half of the total time. Okay, now we can now compute for the, okay, I think we can now compute for the v sub iy using this formula. Okay, using this formula that you have right here. Okay, so next one. Okay, so we all know that the v sub f, or the velocity here, will be 0. All right, because that's the midpoint, that's the highest point or max height that we can achieve. All right, so that is one thing that we need to look forward to. Next one. Okay, now to compute for the v sub ix, so we will not be able to use this one. Okay, we will not use this one, and also we will not use this one. Okay, now we will use this, we will now use this formula because we have range. Okay, we have range and we have the time, which is the 2.5. Alright, we have the time, which is the 2.5 over here, to compute for the v sub ix. Okay, so let's get right into it. Okay, so let's start first with number 4. Okay, let's start first with formula number 4. Okay, so v sub fy is equal to v sub iy minus gt. Then this is 0, so we can eliminate that one. So time is equal to v sub I, okay, over g. Alright, so v sub I over g. Okay, so that is what is v sub iy? Okay. Alright, so sorry. So we don't have the v sub iy, I think. Alright, so we don't have the v sub iy, so we will replace this one. So since we have 0 over here, then the v sub iy is missing, so we will now compute for the v sub iy minus gt. Okay, since we have the time itself, so this is the time. Okay, so we have negative. Alright, so we have negative 9.8. Alright, negative 9.8. The negatives will be cancelled out. Alright, so the negative will be cancelled out because we transpose the VIY on the other side. So negative, so cancelled out. Next one, times 2.5. So cancel the negative. Alright, 2.5. So what will be the answer? Okay, so 9.81 times 2.5. That will be 24.52. Alright, so the VIY will be 24.52 meters per second. Alright, so okay, so we have there you go. Yeah. Okay, so 24.52. Next one. Okay, we will use the same time. We will use the same time that we have right here to compute for the range that we have. Alright, so we will use the same time to compute for the range that we have. Okay, so to compute for the VIX, alright, so to compute for the VIX, so we have x sub f, alright, x sub f is equal to v sub I, x times the time. Okay? Now, what are we going to do here? Okay, now we will compute for the v sub I, which is the one that we need to compute this one. Okay, so we have v sub I, then x sub f over t. Okay, so there you go. Okay, so what do we have on this part? Okay, what do you have on this part? So to compute for the v sub I, so let's substitute all the value. We will not use this time. Alright, we will not use this time because that is on the middle. Alright, now we will use the total time because according to the problem, the object completed the jump. From this clip to this clip that we have right here, it completed the jump, so we will use the 5 seconds. So we have 100 divided by 5. Alright, so 100 divided by 5. So technically, that is okay, so that would be 20. Alright, so that would be 20 meters per second. So that will be our v sub ix. Now, we will label them because they are very important here. Alright, so we will label them. Okay, so let's put them inside the box. And now we are good and ready to go. Now, we are now ready to compute for the v sub I here, over here. We can now compute for the v sub I. So now, how to compute for the v sub I? So, remember the Pythagorean theorem? Alright, so to compute for the v sub I, so we need, okay, so we need to use this one. So, v sub I is equal to square root of v sub I x squared minus, plus v sub I y squared. So, there you have it. Okay, let's substitute the value. So, we got square root over here. So we have 20 squared. Okay, plus. Okay, so what do we have here? 20 squared plus the v sub iy, which is 24.52 squared. There you go. Okay, so 24.52. So there you have it. And with that, okay, so just do the proper math. So squared it, then add, then square root of that. So the v sub I that we are looking for is has the value of 32 meters per second. Okay, so the v sub I that we are looking for has the value of 32 meters per second. So that is our v sub I. So we are done with this one. Okay, now the angle. So what will be the angle? Okay, so what will be the angle? Now the angle, or for the angle, we will use the computation for the angle as angle theta. Okay, tan negative 1, tangent negative 1 times opposite over adjacent. Okay, so opposite over adjacent. So technically speaking, so the opposite here will be the VIY. So we have VIY over V sub I x. There you have it. All right. So let's put on the values here. Okay. So tan negative 1, tangent negative 1 is equal to 24.52 over V sub I x. So that will be 20. All right. So if you do the math correctly, so tangent negative 1. Okay, so 24.52 divided by 20. Okay. Alright, so 24 over 52. Okay, so I'm correct. Yeah. So 24 over 52 over 20. 24.52 over 20. That is 1.26, and we have the tangent 1.226. So that will be, alright, so that will be 50.79, alright, or 51. Alright, so the angle at which the horse jumped is 51 degrees, alright, off the horizontal. So that's how the object jumped. Alright, so I don't know in reality if that is possible. So that is 51 degrees of the horizontal. So there you have it, guys. So that is our problem about a horse that jumped over the cliff with a total time of 5 seconds. All right, next one. Let's have another sample problem. Let's have another sample problem. So I think okay, there you have it. Okay, so I think this will be the last problem that we will going to work with. Okay, so this is the last problem that we will going to work with on today's science video lesson. Alright, so a catapult launches a rock at a castle wall and the rock is launched at 45-degree angle. So let's take note of that. 45-degree angle. Alright, so with a speed of 22 meters per second, the castle wall is 45 meters away. Alright, and the wall is 20 meters high. Alright, so the wall is 20 meters high. So, the question here is, does the rock make it to the wall? Alright, so does the rock will make it to the wall? So that is the question. Okay, so let's, first thing to do is to draw the problem. Okay, so first thing to do is to draw the problem. Okay, so that we will not be able to forget, we will be able to see all the perspective of what the problem are we dealing with. Okay, so let's draw the problem. Okay, so I will just make it thinner. Okay, so that it will not consume space. Okay, so this is a flat, or this is a level ground, and the castle wall is on this side. There you have it. Alright, so the castle wall is 20 meters in height. So from this point down to that point, that is 20 meters. Alright, 20 meters. And this is your catapult. Right, so pardon for my drawing. Right, so this is your catapult. So there you have it, and the rock. Okay, so the catapult is 45 meters away from the castle wall. Right, so that is 45 meters away. There you go. Okay, so the launch angle, all right, the launch angle the rock was launched is somehow 30 degrees. All right, I'm correct. All right, 45 rather. All right, so 45 degrees. Where is that 30 degrees came from? All right, 45 degrees. All right, so what else? Okay, and the speed the rock was launched is let's take a look again. That is 22. Okay, so there you go. All right, it's 22. So we have it right here. So that is 22 meters per second. Okay, so there you go. Okay, now let's break down this one. So we have here, okay, so we have here the V sub ix and the one on top, which is the V sub iy. Okay, now the angle is 45 degrees. Now the question is, will the rock make it to the castle wall? Alright, will the rock make it to the castle wall? So let's write down. Okay, let's write down all the variables. Okay, so the first one is the angle. So that is 45 degrees. Okay, next one. So the V sub I. Alright, so the V sub I stated on the problem, that is 22 meters per second. Alright, so that is 22 meters per second. Next one, the range is 45 meters respectively. Alright, next one, the acceleration due to gravity is negative 9.81 meters per second squared. Now, this is the crucial thing. Now, the object that was launched, alright, the object that was launched is on a level ground. And the object will go, alright, the object will go to a higher ground. Alright, so you get the point. So, the object was launched on a level ground, so the one that we have right here, but the rock itself will go to the higher ground. Alright? So, 20 meters. So, what will be our y sub I here? So y sub I, or the initial height, is 0 meters, and the final height will be, okay, our final height will be 20 meters, and that is the castle wall. Alright? So our final height will be 20 meters, that is the castle wall. Okay. Now, the question here is, will it make it here? Alright? Will it make it here? So, that's the question. Okay, so that is the question. So, in short, we are looking for the y sub f, alright, on this area. Okay, which is 20. Okay? Sorry, not the 20, but what is the final height? Okay, so what is the final height that the object will reach? Alright? What is the final height that the object will reach on this part? Okay, will it reach the castle wall or not? Alright, so let's compute for this one. So first thing to do is to write all the things that we need. So let's start first with, okay, so this 20 over here, we can remove this one so that you will not be confused. Alright, so we are looking for this YF over here. So this is what we are looking for. There you go. So the 20 over here, alright, the 20 over here is only a reference. Alright, the reference that you need to have in order to reason out if the ball or if the rock will make it to the castle wall or not. Alright, so let's have x sub f is equal to v sub ix times time. Then number 2 is okay, so v sub fx is equal to v sub ix. Alright, then number 3, we have, what do we have right here? Okay, so we have y sub f is equal to y sub I plus v sub iy times time minus 1/2 gt. Alright, so 1/2 gt squared. Here you go. Okay, so by the way, disclaimer, we are not using air resistance here, ha? Okay, we are not using air resistance. Okay, ignore the air resistance on our problem. And number 4, we have v sub f y is equal to v sub iy minus g t. There you go. Okay, so what formula are we going to use? Alright, so what formula are we going to use? Okay, let's take a look. Okay, now if we will going to use this one, we have range. Alright, we have range, and we have this one. We will get this one later. Okay, but we don't have time. Okay, but we don't have time. Next one. Okay, next one. Next is for the... Okay, next is for the... Okay, for the final height. Alright, so for the final height, the rock will go through. Alright, so this one, okay, there's a final height, then we have initial height, then on the given, so we have the VIY, which we will get later on this video, and we have the GT, so probably we can use this one. Okay, next one. Okay, so the V sub Fy, so obviously once it hits this one, obviously that will become 0. Alright, so technically speaking, we don't need this one. Alright, so we don't need this, and we don't need this one. So only 1 and 3. Alright, so let's solve for this one. So first, let's solve for the components. Alright, so V sub ix can be obtained by V sub I cosine theta. There you go. Then we have V sub I y is equal to V sub I sine theta. Now, since it is 45 degrees, so both of them are equal. Alright, so let's have it. So we have V sub ix, then V sub iy. So, cosine of 45 times 22. Alright, so we get 15.56. Right, so we get 15.56, 15.56 meters per second. On the other hand, 15.56 meters per second. Okay, so since this is important, so we will box them. Okay, there you go. Okay, next one. Since you have this one already, we can now compute for the time. Alright, we will now compute for the total time. Okay, because we have the range, so the ball, okay, so the ball will go here and it moves over there, so that is the total time. Okay, so we will use this green one. So x sub f is equal to v sub ix times time. Okay, so to compute for the time, so we get x sub f over v sub I x. Then substitute all the value. So what is the x sub f? So we have 45 meters over, what is the v sub I x? So the v sub I is 15.56 meters per second. So cancel the meters. Okay, so the time itself is, okay, 45 divided by 15.56. So that is 2.89. Alright, so the total time is 2.89 seconds. Okay, so we will keep this one in a box. Okay, next one. I'll use blue one. Okay, now since we have the total time, now we will now find if the ball or if the rock will make it through the castle wall that you have. Okay, so let's compute for this one. So we will use this formula. So yf is equal to y sub I plus v sub iy times time minus 1/2 gt squared. Okay, so since this is 0, so we can ignore that one and proceed with the computation. So v sub I is v sub iy is 15.56, right, times the time, which is 2.89. 2.89. Okay, so minus 1/2 9.81, right, times 2.89 squared. There you go. Now if you do the math correctly, okay, so if you do the math correctly, you will get a yf of, all right, you will get the yf of 4 meters, right? So you will get the yf of 4 meters. So what does it mean? Okay, so what does this one means? It means that, okay, the ball or the rock itself, this one, okay, so the rock itself will not make it through the wall because it will only get to 4 meters. Then you will still have 16 meters. Okay, you still have 16 meters to go through the castle wall. Okay, to make the wall, to make the rock, all right, to make the rock, okay, go inside the wall. So only 4 meters. So it is short. Okay, your rock will fall short on the castle wall. So the final verdict is it will not, okay, it will not make it through the castle wall. Okay, so there you have it. So that is our last problem for the topic projectile motion. Now, okay, so I hope you did learn something from this sample problems that we computed. Okay, so if you gain value from this video lesson, just hit the like button, okay, on the bottom of this video. Now, if you want to be updated with more videos like this in the future, just hit the subscribe button and bell button, all right, beside it. Okay, now if you have a question regarding the video, all right, about something on the video, you can write it on the comment section as well as the suggestions. All right, so that ends up our video lesson for today. So I think, so let's see each other for the next video lesson in science. So peace out, everyone.